Factoring polynomials of quadratic form. I want you to notice something here. First, I want you to think of this. This is what you're used to factoring. This is a quadratic trinomial. And what I'm doing is changing the form a little bit, right? So I want you to notice that, so you can have a leading coefficient, a, x, and you have an even exponent. So it's an even number exponent. And then the middle term will have half that even number, okay? And of course, there's a b, is the coefficient, like b is 5 here, and a constant, okay? So here's a weird example. What I'm doing is I'm claiming that you can have an even exponent plus 5x half the even exponent and minus 6. So this is the lowest it could be, right? 2 is the lowest even number. So this has that form, x to the second plus 5x minus 6. So this is a quadratic. And we can factor like this. If you can factor without this, that's fine. I'm just reminding people. So here we have a negative 6. You put that on the top. 5, put that on the bottom. And what are the factors of negative 6 that combine to make positive 5? That will be positive 6, negative 1. 6 times negative 1 is negative 6. 6 plus negative 1 is positive 5. And you just do x plus 6, x minus 1. And that's that, right? There are no exponents left, okay? So that's it. You're done with factoring. Now, so the quadratic form we can be, it's going to look like this, right? 10 is an even number, and 5 is half of 10. So it's x to the 10th plus 5x minus 6. But you're going to treat it just like this one. So here, x to the 1, that's half that exponent. So we take x to the 5th. We still have the plus 6. X to the 5th again. And then we have the minus 1. So that's it. So now you can factor trinomials in the quadratic form by using the same techniques to factor regular quadratics. And all we do is take half the exponent. Now, the only difference between this and the regular quadratic is that this might be factorable. Okay, so this might be factorable. This one isn't. X to the 5th. We don't have any rules about 5th power. Okay, we have rules about cubes or squares or 4th power, but not 5. All right. Now, in the classroom, I would just ask the students to give me a number. Well, I'm going to just choose one randomly. I'm going to choose 8. So what if I had x to the 8th plus 5x to the 4th minus 6? So that's our example. And we're going to factor that. Okay, I'm kind of focusing here. So that's going to be x to the 4th plus 6, x to the 4th minus 1. Right? So I just took half that exponent, and I used the same numbers, right? 6, negative 1, because my numbers didn't change. 5 and negative 6, 5 and negative 6, 5 and negative 6. So the factors are still basically the same. Only thing that's different is that exponent. But here's the bad news. So this one can be factored further, because what I have now is a perfect square minus a perfect square. So make sure you watch the other video before you watch this one, because this is a difference of 2 squares. Now, this is a sum, so that cannot be factored further. So I just copy that down. And x to the 4th can be done x squared plus 1, x squared minus 1. Right? That is the result of factoring a difference of 2 squares. Right? An even exponent makes it a perfect square. Right? When I mean perfect square, it's x squared times x squared that gives me x to the 4th. So it's x squared times x squared. I'm not saying 4 is a perfect square. It is, but that's not important. If I had x to the 6th, that would be x cubed times x cubed. So 6, because it's an even exponent, is considered a perfect square here. Alright, but anyway, so x squared plus 1 cannot be factored, even though that's a perfect square and 1 is a perfect anything. But there's a plus sign there, so that cannot be factored. But this one, that is another difference of 2 squares. Because I have a perfect square minus, it's the difference of 2 squares, and another perfect square. So, copying the x to the 4th, copying this one, right? Those two cannot be factored any further. But x squared minus 1 is x minus 1 times x plus 1. Order does not matter here. If you put x plus 1 first and x minus 1 second, that's okay. Alright? Alright, so that's it. That's the final answer of that example. Alright. So how do I know to stop here? Well, the exponent is 1. So that's why I stopped. Right? Here I needed to check. Can this be factored? Well, it's a plus sign. So no. This is also a plus sign. Even exponent, but plus, and there's no other x's involved. So you stop. Alright, let's go. There are 4 examples that I'll work through here. Alright, so this is a typical quadratic form. I have a leading exponent is even, middle exponent is half of that, right? 3 is half of 6. So I'm looking at the factors of -8 that combine to make -2. And that's going to be -4 and +2. So that's going to be x cubed minus 4, x cubed plus 2. All right, I take half that exponent, and just put in the -4 and +2. And that's it, okay? 4 is not a perfect cube. 2 is not a perfect cube, so that's it. That's done. I'm done. That's finished. So the only way these could be factors if that were a perfect cube and that were a perfect cube, okay? Because I have a perfect cube and then just another addition or subtraction sign. There's no other middle term like x or 2x or whatever. All right, moving on to example 2. Again, I have an even exponent and then half that exponent. So this is quadratic form. And this one has a leading coefficient. Whenever you have a leading coefficient, you have to multiply those two. You have to do 6 times -15, which makes -90. And you want to add up to -1. You want to combine them to make -1. That'll be -10 times +9. -10 times 9 is -90. -10 plus 9 is -1. All right. So, and then remember, this is the Lizzie method. So I write x, and I use that exponent. So it's x squared minus 10 over the leading coefficient of 6 squared minus, it's plus 9 over 6. All right, so the minus 10 from here, plus 9 from there. And then I reduce this. So that's x squared minus 5/3 and x squared plus 3/2, right? Reducing it. Then move my denominators up. So it's 3x squared minus 5 and 2x squared plus 3. And there we go. All right, that's a square, but 3 is not a perfect square, so stop. Square, 2 is not a perfect square, so stop. All right, so that's my final answer there. That's example 2. Example 3. All right, factor this out. What are the factors of 1 that combine to make -2? -1 times -1. -1 times -1 is +1. -1 plus -1 is -2. So that's it. I take half the exponent, so it's x squared minus 1, x squared minus 1. Now, this is a difference of 2 squares. X squared is a perfect square, 1 is a perfect square, so you factor this. So x squared minus 1 becomes x plus 1, x minus 1. And you got to do it again because you have the same thing over here. So x plus 1, x minus 1. Now, it is perfectly alright to give your answer like this. X plus 1 to the second power, x minus 1 to the second power. Alright? So either answer are acceptable for me. Right? You can give me either one. Either one is fine. And as a reminder, what this is saying, this has a multiplicity of 2. Right? Remember our definition of multiplicity? Right? This has a multiplicity of 2, and this has a multiplicity of 2. We're going to talk about roots later. Roots about next week. Alright. Let's take a look at this one. So you have an even exponent, you have half of that. Alright, take the 8, take the -9, multiply that, you get -72. Middle term is -71. What are the factors of -72 that combine to make -71? Well, -72 and +1. Yeah. I know some people go, oh, well, anyway, whatever. Alright, so it's Lizzie method because I have a leading coefficient. So I'm going to do x to the third, you take half that exponent, minus 72 over the leading coefficient of 8, and x cubed again, plus 1 over 8. Reduce, it's going to be x cubed minus 9. This one cannot be reduced, so you bring the 8 forward. So it's 8x cubed plus 1. Alright, so that's that. Now, 9 is not a perfect cube. It is a perfect square, but it's not a perfect cube, so you can't do anything with that because that's a cube. That's not a square. All right. However, here 8 is a perfect cube and 1 is a perfect cube. So this is a sum of 2 cubes. This is a sum of 2 cubes. So I'm just going to copy the x cubed minus 9 because I can't do anything with that. 9's not a perfect cube. So take the cube root of that combination. That's 2x, right? 2 to the third is 8, and x cubed is x cubed. Plus, you keeping that sign, cube root of 1 is 1, right? 1 to the third power is 1. You then continue on with the formula. You square that first term, so it's 4x squared. Change the sign, multiply those two, right? So that's a minus sign there. You can't see that. And then plus, the last term is always plus, square the second term. So 1. And that's the answer to that one. Remember that the trinomial here, if the exponent is 2, cannot be factored. So just leave it alone. Alright, that's the end of the lesson. Oh, actually, no, let's stop for a minute. Some of the worksheet problems, you might see a problem that looks like this. Let's see. Right? Where you see a problem that looks like this, and you go, well, that's not an even exponent. Well, if you checked, there is a common variable of x, right? If you see an x in the last term, that means there's an x in all of them, right? So that's a little different from what we solved earlier, right? There's no x on the last term. Okay, so watch out for that. So that means there's a common variable here. You need to take out the common variable. So I take out the common variable, I get x to the 6th plus 7x to the 3rd plus 12. Now I have an even exponent and half that exponent. And then I just do this thing. I want the factors of 12 to combine to make 7. That'll be 4 and 3. That x comes for the ride. But that becomes x cubed plus 4, x cubed plus 3. Alright? Now, 4 is not a perfect cube and 3 is not a perfect cube. So that's it. That's the final answer for that one. Okay. Now I'm in. Now I'm done.